Okay, welcome back. Uh, Today we are going to start with a new chapter, and the first method that we are going to see in this chapter is called as a Gauss elimination method. Okay, in the last chapter what we saw were different methods, different iterative methods to solve the equations. Those were mainly non-linear. Exponential, then polynomial kind, trigonometric functions and whatnot. But in this chapter what we are going to deal with are going to be simple linear algebraic equations, multiple variables and multiple equations, right? Okay, so basically what we will have here is you will have equations given in the format like this: a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. Okay, these are the kind of equations that we'll have, and what we have to do is we have to get the values of x and y and z, or maybe 4 variables, 5 variables, 2 variables, how many variables you have. We have to calculate the values of those that satisfy all these equations, which means that the point of intersection at which all these 3-dimensional lines intersect with each other. Alright, so these are simple linear algebraic equations. Alright, how to solve these? The first method, Gauss elimination. In this what we do is we are going to express these 3 equations that are given to us in the format like this. Okay, a1 b1 c1, a2 b2 c2, a3 b3 and c3 multiplied by x y z is equal to d1 d2 d3. Okay, now what we are seeing here are 2 matrices. This matrix is a 3 by 3 matrix, and this one is a 3 by 1 matrix. Okay, so when we are going to multiply this, what we'll have is another 3 by 1 matrix. Okay, so that is going to look something like this: a1 into x plus b1 into y plus c1 into z is equal to d1, right? So the row below this, a2 into x, b2 into y, c2 into z, and similarly the third row, a3x plus b3y plus c3z. Okay, this is going to be equal to d1 d2 d3. Okay, now if you compare this multiplication that we have gotten with the initial set of equations that we had, see the first row here is similar to the left hand side of this equation. d1 remains as it is here. Similarly with the second equation and second row here, and third equation here and third row here, right? So basically I just did this to prove to you that the equations that have been given to us can be expressed in the format of a matrix like this. Okay, alright, so what we are going to do here is, for convenience purpose, we are going to write this equation. The x, y, z matrix we are going to ignore for the moment. Okay, and just we are going to express this in terms that a1x, a1 b1 c1, a2 b2 c2, a3 b3 c3. Just going to put a line in between here and going to put d1 d2 d3. Okay, all right. This line represents that there is a multiplication by xyz matrix in between there. Alright, I have done this because if you remember in the 10th standard when we had to solve the equations of this kind of something a1x plus b1y is equal to c1 or stuff like that, what we used to do was subtract one equation from the other, subtract the third from the second from the first. We did processes like that to make sure that what we got was we used to eliminate one by one the variables, and at the last step we used to get an equation where one of the variables only remained there, right? So we got the value of that, substituted that value in the previous and the two values in the first one. That's how we used to calculate the values of xyz. The process we are going to follow here is the same one, just we have reduced it to a matrix format to make sure that this process is speedy, because if you consider that the equations here are suppose there are two variables and two equations, or three variables and three equations, this process is simple. But if you go for higher variables, which is very much likely, then you do not have the luxury of spending too much time in eliminating these. So this method is a bit more faster and easy to apply. Okay, so that's how we are going to proceed. We are going to make sure that this triangle right here, okay, this triangle becomes 0. The a2, a3 and b3, these three elements become 0, and after that we are going to get just the value of something like, instead of c3 there will be some other value here, that something is equal to some other value. So we're going to get the value for z, we're going to substitute that in this and the two values in this one, right? Okay, easier done than said. So let us start with our first example, and that is going to help you understand this a little bit better. Okay, all right, let me give you an example here. Okay, let's start with this one. The one right here. The first one is x plus 4y minus z is equal to minus 5, x plus y minus 6z is equal to minus 12, 3x minus y minus z is equal to 4. Okay, alright. So these are the three equations that we have. Let us express them in the format like this. Okay, so this matrix is going to look like 1, 4, minus 1. I'm going to put a line here, and minus 5. Then 1, 1, minus 6, minus 12, and 3, minus 1, 4. Completing it here. Okay. So this is the matrix that we are going to have initially. Alright, so let us take this a little bit further. I'm just going to copy it down again for our reference right here. This is 1, 4, minus 1, minus 5, okay, 1, 1, minus 6, minus 12, and 3, minus 1, 4. Okay, now as you can see, the multipliers of this row right here, first row, first column element right here, 1, and this one are the same. As I told you, the triangle that we have to make 0 is this one, right? So if I just subtract this row from this row, then that's going to give me something, 1 minus 1, this element will become 0. So that's what I'm going to do first. So it's going to be R2 minus R1. Okay, so this process becomes the first row remains as it is, 1 4 minus 1 minus 5. Okay, 1 minus 1, that gives me a 0. 1 minus 4, that gives me a minus 3. Minus 6 minus 1, so minus 6 plus 1, that gives me minus 5. And minus 12 minus 5, so minus 12 plus 5, that gives me a 7. Okay, the third row remains as it is, 3 minus 1 minus 1, 4. Okay, so as you see, we have done the first element has become 0. Alright, now this one, let us concentrate on this one. So this is basically 3 and here is a 1. So if I multiply this row by 3 and subtract it from this row, that should give me a 0 right here. Okay, so that's what I'm going to do. R3 minus 3R1. Okay, right, got this? R3 minus 3R1. So this becomes first row again remains as it is, 1 4 minus 1 minus 5. Second row remains as it is, 0 minus 3 minus 5, 7. I'm sorry, this is a minus 7. Minus 12 minus 5, minus 12 plus 5, so minus 7. Minus 7. And 3 minus 3, that gives me a 0. Okay, minus 1 minus 3 into 4, so minus 1 minus 12, that gives me a minus 13. Okay, and minus 1 minus of 3 into minus 1, so minus 1 minus of minus 3, minus 1 plus 3, that gives me a 2 plus 2. Okay, and 4 minus 3 into minus 5, so 4 minus 15, so 4 plus 15, that gives me a 19 right here. Okay, so that's how it's going to look. The two elements here, they are 0. Alright, okay, and finally there's a minus 13 here, there is a minus 3 here, right? So if I multiply this row by minus 13 by 3 and subtract it from this one, that should give me a 0 here. Alright, so R3 minus 13 by 3 R2. Okay, alright, so first row again remains as it is, 1 4 minus 1 minus 5. Okay, second row remains as it is, 0 minus 3 minus 5 minus 7. Okay, as it is. And now 0 minus 0, that's again going to be 0. So and one thing I want to tell you is, when dealing with fractions, please don't be shy to make rough calculations here. Okay, so minus 3 multiplied by 13 by 3, right? So 3 and 3 are cancelled, this becomes minus 13. So minus 13 minus 13, so minus 13 plus 13, that gives you a 0 right here. Okay, now 2, which is, we can represent it as 6 by 3. Okay, minus 13 by 3 multiplied by minus 5, right? So this is going to give you 6 by 3 minus 13, minus becomes plus, 6 by 3 plus 13 into 5 is 65 by 3, right? 6 and 65, this gives you a 71 by 3. And next is 19 minus 13 by 3 into minus 7, right? So the 19 is 57 by 3, minus becomes again plus, so 13 into 7 is 91 by 3. Okay, so all of this becomes 57 and 91, so that's going to be 148 by 3. Alright, as you see, there is no shame, remember these words very carefully, there is no shame in doing the calculations in the rough. It may seem a little bit kind of like bit too easy of an approach, seems like you cannot do it in your mind or something, but it's always better to go for a manual calculation rather than making some silly mistake and losing your marks over here. Okay, so always, if you are not sure about these, or the fractions are becoming a bit too difficult, like in this case here, 19 minus 13 by 3 into minus 7, you can always just do this. Okay, so my advice is do this. Alright, so as you can see here, all the three elements, these have become 0, and in the last row, as you can see, there is a single variable which has a multiplier. The remaining two have become 0, so we can substitute this right here. So what we say is 71 by 3 z is equal to be 148 by 3. Okay, so z is equal to 148 upon 71. Let's see how much that is. That's 2.0845. Z is equal to 2.0845. Now over here in the second equation, the x is 0 and y and z have multipliers, so let us substitute this there. So minus 3y minus 5 into bracket 2.0845 is equal to minus 7. Okay, alright, so now minus 5 into 2.0845. okay, if we transfer this on that side, then I'm sorry, so minus 3y is equal to 3.4225, so y is equal to divided by minus 3 minus 1.1408. okay, answer 1, answer 2, and substituting both these values in the first equation over here, 14 minus 1 is equal to minus 5. Okay, as you see, this is the calculation that I've done. Okay, and finally x minus x plus 4 into bracket minus 1.1408 minus 2.0845, that's equal to minus 5. Therefore x is going to be equal to minus 5 plus 2.0845 plus 4 into 1.1408. Okay, let me just tally these answers with the textbook. I hope they're right. .6478, okay, minus 1.1408, 2.0845. Yes, they are absolutely right. Okay, so 2.0, these are the three answers that you have. Okay, so please concentrate on this method. First thing, converting this element into a 0. Next thing, this one into a 0. Last thing, converting this one into a 0. Okay, tip is, do not be afraid or shameful to do your calculations in this manner. Alright, I still do it, so better to go with a kind of a method from the past than making a mistake, as I told you. Okay, so follow this, and after that when you get these two 0, you get a value of z that is equal to 0. So I'm sorry, the other two variables are 0 and a value of z that has a value, so you can just get the value of z directly, and substituting these values in the previous equations, get the values of x and y. Okay, alright, let us do one more. Okay, and after that we'll go to the next method. let me just get a new one. Alright, let us go for a bit complicated one. Okay, this one goes like this: x plus 2y plus 3z minus u, that's equal to 10. Okay, 2x plus 3y minus 3z minus u, that's equal to 1. Okay, 2x minus y plus 2z plus 3u, that's equal to 7, and 3x plus 2y minus 4z plus 3u, that's equal to 2. Alright, let me just check this. X plus 2y plus 3z minus u is equal to 10. 2x plus 3y minus 3z minus u is equal to 1. 2x minus y plus 2z plus 3u is equal to 7. Alright, that's correct. Okay, now we have the 4 equations. As you can see, there are 4 variables and 4 equations. Now let us convert them into a matrix form. Okay, 1, 2, 3, minus 1, that gives us a 10. Okay, 2, 3, minus 3, minus 1, that gives you a 1. Alright, then 2 minus 1, 2, 3, that gives you a 7, and 3, 2, minus 4, 3, that gives you a 2. Alright, so we have a matrix form. We are ready to do the transformations. Alright, so let us start with this one. Okay, R2 minus 2 R1, and similarly I'm going to do 2 or 3 operations in one step here. Okay, as you can see, here's 1, so simply by multiplying this row we can convert all these 3 rows. So R2 minus 2 R1. Okay, let me start with this. First row remains as it is, so 1, 2, 3, minus 1 and 10, that remains as it is. Okay, R2 minus 2 R1, that's going to be 2 minus 2, 0. Okay, after that 3 minus 2 into 2, so 3 minus 4, that gives you a minus 1. Okay, minus 3 minus 2 into 3, so minus 3 minus 6, that gives you a minus 9, and minus 1 minus 2 into minus 1, so minus 1 minus minus 2, so minus 1 plus 2, that gives you a 1. Okay, and 1 minus 10 into 2, 1 minus 20, that gives you a minus 19 over here. Alright, okay, next is in the same step itself I'm going to do another one. Here you can see a 2 and 1, so we can follow the same step again. R3 minus 2 into R1. Okay, that gives you 2 minus 2, it gives you a 0. Minus 1 minus 2 into 2, minus 1 minus 4, that gives you a minus 5. Okay, alright, next is 2 minus 3 into 2, so 2 minus 6, that gives you a minus 4. Okay, 3 minus 2 into minus 1, so 3 minus minus 2, 3 plus 2, that gives you a 5. And finally 7 minus 10 to 7 minus 20, that gives you a minus 13 here. Alright, I hope that's clear. Alright, and finally here you see a 3 and 1, so what I can do is R4 minus 3 into R1. Alright, so this is going to give you 3 minus 3, that gives you a 0. 2 minus 3 into 2, so 2 minus 6, that gives you a minus 4. Minus 4 minus 4 minus 3 into 3, so minus 4 minus 9, that gives you a minus 13. Alright, here, and 3 minus minus 3, so 3 plus 3, that gives you a 6 over here. Okay, and finally 2 minus 3 into 10, so 2 minus 30, that gives you minus 28 over here. Alright, so I think that's clear. So basically in the first step itself we have converted 1, 2 and 3, these three elements to 0. What we have to do is now concentrate on these three, 1, 2 and 3. Alright, okay, so next what I'm going to do is I'm going to be converting these two into 0. Alright, so as you can see there is a minus 1 here, minus 5 and minus 4. So this way I can do that. Okay, first thing I'm going to do is R3 minus 5 into R2. Okay, now as I told you beforehand, 1, 2, 3, minus 1 and 10. This row remains as it is. Next is 0, minus 1, minus 9, 1, minus 19. This row remains as it is. Okay, next is 0 minus 5 into 0, this remains 0. Okay, minus 5 minus 5 into minus 1. Okay, so minus 5 minus 5, minus 5 plus 5, this becomes a 0. Minus 4, okay, minus 4 minus 5 into minus 9, so minus 4 minus 45, minus 4 plus 45, that gives you plus 41 over here, and 5 minus 5 into 1, so this gives you a 0 here itself. Alright, and minus 13 minus 19 into 5, so minus 13 plus 95, right? Minus 13 plus 95 is plus 82. Okay, so here itself. And now with the final one, as I told you, we have to convert this one to 0, which is going to give you minus 4, this row, which is R4 minus 4 times R2. This is going to give you a 0 minus 0, this remains a 0. Minus 4 into minus 1, so minus 4 plus 4, that becomes a 0 again. Next is minus 13. Okay, minus 13 minus 4 into minus 9, so minus 13 plus 36, that gives you a 23. Okay, and finally 6 minus 4 into 1, so 6 minus 4, that gives you a 2. 28 minus 19 into 2, so 19 into 4, I'm sorry, so minus 28 minus 4 into bracket minus 19. Okay, so this gives you a plus 48 here. Alright, so now as you can see, very interesting thing has happened here is, because the elements here, they were of a similar kind, had the similar signs, minus 1, minus 5 and 1 and 5. So when we subtracted them, here itself the three elements became 0, right? So we can stop right here. Instead of doing this one, converting this one into a 0, we can stop right here and we can just convert this row into a real value. So this one, as you remember, x, y, z and u, so this is a z element, so this gives us 41z is equal to 82, therefore z is equal to 2. Okay, one of our answers right here. Okay, now substituting this value in here. Okay, so 23z plus 2u is equal to 48. Alright, so 23z is 23 into 2, 46. So 2u, 46, transforming from here to here, so 48 minus 46, therefore 2u is equal to 2, u is equal to 1. That's another of our answers. Okay, you see that. Alright, now substituting these two in the one above, that's going to give you minus 1y minus 9 into z, so 9 into 2 plus 1 into bracket u, which is 1, is equal to minus 19. Alright, so minus y is going to be equal to minus 18 and I'm sorry, so minus 18, taking these minus 18 on the right hand side, we're going to get and this 1, so minus 18 plus 1, right, minus 18 plus 1, that gives you a minus 17 right here, transforming it there, so minus y is going to be equal to minus 2, therefore y is equal to 2, right? So this is the third of our answer, and these three values, let us substitute these in the equation on top, so that gives you x, okay, plus 2y, so y is equal to 2, so plus 2 into 2 is 4, okay, plus 3z, so 3 into 2, that's 6, and minus u, so minus 1, that is equal to 10, it says, okay. So 4 plus 6, 10 minus 1 is 9. Taking it to that side, x is equal to 10 minus 9, x is equal to 1. Okay? That's the fourth of your answer. So x, y, z and u, 1, 2, 2 and 1. Right? So that's your answer right there. Okay. So now I hope this method is clear to you. There is one more tip that I can give you. Here, as you can see, we could convert all these three values to 0 right in one step, because there was a 1 right here. Alright, so it is advisable to convert this first row such that the multiplier of x in the first equation becomes 1. Okay, so let me give you an example. For example, suppose the first equation is something like this: 3x plus 6y plus 9z is equal to 12, suppose something like this. Then what you can easily do is divide all this equation by 3, so that's going to give you x plus 2y plus 3z is equal to 4. Okay, so as you can see here, just dividing this equation by 3, we converted this, the multiplier of x here, which goes right here, to 1. Okay, so you can easily just do this: r2 minus 2 r1, r3 minus 2 r1, r4 minus 3 r1, something like that. Okay, so that's one more tip for you here. So I hope this is pretty clear, and with the examples that we have been solving in the class, it should be pretty easy to do this at the time of your exams. Alright.